So we just learned about some of the fundamental shapes that we might see in functions. So we learned about bowl-like functions. And the example you were given there was f of xy is equal to x squared plus 4y squared. We learned about saddle-like functions. And the example you were given was f of xy is equal to x squared minus y squared, and canyon-like functions. And the example we had was f of xy is equal to x plus y quantity squared. Now, let's consider a general quadratic function. And I'm going to make the assumption that f at the origin, f of 0, 0 is equal to 0. Otherwise, we'd need one extra term in the formula for the general quadratic. But the ones we'll take a look at have the general form f of xy is equal to some constant times x squared plus some constant b times xy plus some constant c times y squared. And in fact, all of the functions for the bowl, the saddle, and the canyon have this function. Maybe you have to, in the canyon function, maybe you have to multiply things out, but all of them can be written as some, as a general quadratic for some choice of A, B, and C. Now the question is, given the function, right, given the definition, by which I mean some particular choice of A, B, and C, right, can we determine the shape, right? Bowl, saddle, canyon. And we'll have some more formal definitions. We'll give some more formal definitions to a bowl, a saddle, and a canyon in a moment. But for now, let's just say, can we determine the general shape? Okay, so that's our question. All right, well, let's take our canyon function, x squared plus 2xy plus y squared, right? And that particular function factors as x plus y quantity squared. And so the idea that we're going to pursue is to reduce any f, quadratic f, to one of three forms. Okay, one of three forms. And we'll say, I won't write f of xy, but I'm going to say, well, f could be equal to something like u squared plus v squared, right, where u is a function of x and y, and by which I mean a linear function, something like, like a constant times x plus another constant times y. And we won't be too specific yet. So linear function of x and y. And also v is a linear function of x and y. Okay, so we have the first up, f equals u squared plus v squared. Anything that I can write in this form is going to turn out to be a bowl. Anything that I can write in the form u squared minus v squared, right, is a saddle. And then the last type, when I have, right, so now we'll go f equal to u squared. So if I can write it as just something squared, this is what we have for a canyon, right? And these are our three fundamental shapes. And as a starting point, right, go back and take a look at our function x squared plus 2xy plus y squared, right? And originally we had it written as quantity x plus y squared. And so the question would be, say for, right, if I'm given f of xy is equal to x squared plus 2xy plus y squared, how do I go from that to understanding that this is a canyon function? This particular one is kind of easy because we could probably eyeball it and see that it's equal to x plus y squared, right? So in this case, we have u is equal to u is equal to x plus y, and v is equal to 0. All right. So in a general context, we have to figure out how to factor these functions, right, in some nice way. All right. So there's a trick to this, and quite honestly, I don't regard this technique is the world's most practical skill. So if you get something on an exam or something on a quiz on how to do one of these problems, it's not going to be a really, really hard one. It'll probably be something relatively simple. Okay, so let's go back to our general function, ax squared plus b times xy plus c times y squared. And now what we'd like to do is figure out how to rewrite this as a function related to a u squared term and a v squared term. And there's no reason why it should be immediately obvious to you how to do this, right? But let's go ahead and figure it out ourselves, or at least see why it works. Okay, so the first thing you want to do is factor a out, right? So then we have a times x squared plus b over a times xy plus c over a times y squared. And it's relatively easy in terms of classifying, whether or not you have a saddle or a bowl or something like that. Okay, and so the inside here we can actually rewrite as x plus b over 2a y quantity squared plus 4ac minus b squared over 4a squared times y squared. And again, there is no reason whatsoever why that should be immediately obvious to you. It's just a formula that works, right? Because you can go ahead and check that this x squared plus b over 2ay, right? When you multiply that out, here you get a times x squared plus b over a times xy plus b squared over 4a squared y squared. Okay, so that's what you get. And then over here you can see that, right, if this last part of the term here, right, this minus b squared over 4a squared, that's going to actually cancel out the third term in this, right? And so let's go ahead and add all that back in, right? So here we have 4ac minus b squared over 4a squared y squared. And if I simplify this further, right, I'm gonna get rid of this b squared over 4a squared term, And that's good because it's going to cancel with this other term. And once I do some additional cancellations, right, I'll get c over ay squared left over. Right, so you can see that, and this, one thing I just want to quickly point out is that the parentheses go out here, not in here, right? So a multiplies through this entire equation. All right, so if I keep going here, right, you can see I multiply it out, I get ax squared plus b times xy and the b squared over 4a squared times y squared term is going to cancel out, and what I end up with is 4 times ac over 4a squared y squared, and you can see that this all simplifies to ax squared plus bxy plus cy squared. Right, so we took kind of a long detour, you know, to see, you know, to kind of see why this formula here, right, this more complicated formula is the same as the simple polynomial, the simple quadratic function that I wrote up originally. And the method is called completing the square because what you do is you figure out, right, so you figure out what this squared term should be, this x plus b over 2a times y quantity squared, and then you have this leftover bit. And in fact, it's this leftover bit here that tells you everything you need to know about the shape of that function. Right, so what we'll do in this case, right, so what we'll do in this case is we'll set u equal to x plus b over 2a times y. Okay, and so you can see then that this first term, right, this first term here, that's u squared. Okay, and then this second term has to be either 0, v squared, or minus v squared. Right? There are no other choices. So what we need to do is we need to put some conditions, right? So if v is equal to 0, we're going to have a canyon, right? Because there will only be a u squared term, and then right, that's equivalent, right? That's equivalent to 4ac minus b squared over 4a squared is equal to 0. Or if we wanted to be simpler about it, because we can tell, again, pretend a is never 0, right? But if we wanted to, we could also just make the condition totally about the numerator, right? Because the denominator is always positive if we assume a is not 0, so it won't actually change the answer. So for a canyon, right? So for a canyon, we have this condition here, which says that 4ac minus b squared is equal to 0. Let me just shrink some of the calculations and get them out of the way. There we go. All right, and my first, right, so my first condition was, for a canyon, was, right, so u would be equal to x plus b over 2ay, and v is equal to 0. So that's one possibility, right? Well, what's another possibility? So if 4ac minus b squared is greater than 0, you can see that, right, in my formula that the coefficient sitting in front of y is positive, right? You can see that. And so in that case, we're going to have, right, we're going to have v equal to the square root of that big mess, right? So v would be equal to the square root of 4ac minus b squared over 4a squared, okay? And all of that times y, okay? So in this case, we'll always have u equals x plus b over 2a times y. Okay? And then in this case, v is equal to the square root of 4ac minus b squared over 4a squared times y. In this case, I was able to write my function as f of xy is equal to u squared of xy plus v squared of xy. So this is a bowl. Okay. And then the last possibility, and let's just come up here and use this leftover space. The last possibility is that I'm going to have a saddle-like function. And the saddle-like function occurs, right? So the saddle-like function, I know that my function will be of the form f of xy is equal to u squared of xy minus v squared of xy. And in this case, u again, it will be equal to x plus b over 2a times y. Okay, and then in this case, v will be equal to the square root of, right, so this, this term I'm interested in is negative. So if I want to take a square root, I'm going to have to put a negative sign in front of it. So in this case, it will be, or flip the two terms in the numerator. So I can write b squared minus 4ac over 4a squared and then times y. And in this case, right, then we'd have f equal to u squared minus v squared. Now, in fact, I should be slightly more rigorous and point out that I factored out an a. So really, it's a times u squared minus v squared. I think these problems are a lot easier to understand and process if you just assume a is 1. So if you're going to get any exam questions, if you can do the case where a equals 1, you're probably in pretty good shape. All right, so let's go ahead and problem for you to try it out. Let's just try one simple factor of the square problem. So go ahead and try it out. Hit pause on your recording and see if you can work it out for yourself, and then we'll come back in a minute and show the results. All right, we are back. Okay, so now we'll come back and work on the example f of xy is equal to 3x squared minus 6xy minus 9y squared. And again, it's totally fine to make a function g where we just divide through by 3 so that we get x squared minus 2xy minus 3y squared. And the first thing we want to check is the sign of 4ac minus b squared. Again, remembering that we've designed our modified problem so that a is equal to 1. And we can see that this is 4 times minus 3, right? So we have 4 times minus 3 minus b squared. So that's minus 2 squared. And so we have minus 12 minus 4, and that's less than 0, right? It's minus 16. So we do our same trick, right? We factor g. We start by setting u equal to x plus b over 2a y. And again, remembering that a is 1. Okay, and then we have x plus minus 2 over 2y, which is x minus y. And for v, so now we have v is equal to the square root. We better have something positive. So we don't want 4c minus b squared. We want b squared minus 4c divided by, and in fact it's ac over 4a squared. For our particular problem, a is 1. So again, we get rid of some of this noise. And all of this is times y. And so we calculated 4c minus b squared as minus 16. So, right, when we just flip the sign of this, we have 16 divided by 4 times y. And you can simplify all of that and see that it equals 2y. Okay, so now if we go back, we can see that g of xy is equal to u squared of xy minus v squared of xy, where u is equal to x minus y, and we square that, and then we subtract off 2y quantity squared. So let's go ahead and multiply all of that out. Just make sure we did everything correctly, right? You can always check your work on these problems by multiplying out the polynomial. Here we have x squared minus 2xy plus y squared minus 4y squared. And if I go ahead and simplify that, I can see I get what I wanted, which is x squared minus 2xy minus 3y squared. Check, right? And then our original function f of xy is simply equal to 3 times g of xy. Right? That's all we did was pull out a 3. Now, the one thing to be aware of is when you simplify the problem, right? When you simplify the problem, it matters just a little bit whether or not you have a positive coefficient or a negative coefficient. And let me just explain why. Okay. So if I have something like 3u squared minus v squared, that is always something we call an indefinite function. Okay? It's saddle. It has one direction that curls up and one direction that curls down. Now, if I have 3 times u squared plus v squared, this is something we call positive definite. It has 2 curvatures. It has 2 positive curvatures. And we don't know that much about curvatures yet, but just, right, so just try to picture that we have 2, it's curling in the same direction, right? It's curling in a positive direction in both dimensions. On the other hand, if we wrote minus 3u squared plus v squared, this is something we call negative. negative definite, right? So it has, instead of a bowl, it looks like the top of a mountain, right? It looks like a bowl turned upside down. So when the curvatures are kind of curling up, right, or the function is increasing as I go away from its minimum value, that's positive definite, right? So that's positive definite. It looks like this function, some 3u squared plus v squared. On the other hand, if I tip the bowl over or have a mountain, you have a peak of the mountain, and then as you come away from the peak of the mountain, the function value decreases, and this is what we call negative definite. And then the third, right? So this is like bowl, and this is peak. Okay, and then the other options we have, right? So we have 3u squared, and this is what we call positive semi-definite. So it has a curvature in one direction, but in the other direction, it's flat, right? And so instead of being definite, it's semi-definite, right? Because you only have this well-defined curvature in one direction, and the other has a zero curvature, right? So this is a canyon, and I'll put canyon up. Okay, and then the last option we have is a function of the form minus 3u squared. And so a function like that has a shape something like this, right? It's not a canyon, it's like a canyon turned over. So it's kind of like it looks like a ridge. Maybe we can call that a ridge function. And this particular form we call negative semi-definite. So that's a ridge-like function. And basically, for quadratic functions, these are the only options you have, is one of these 5 type functions. So then the thing that can happen here is if you're given a function, right, with a positive coefficient and you change f to g by factoring out that 3, you won't change, right? If you have if f is if f happens to be a positive definite function, then g will be a positive definite function. If f is positive semi-definite, then g will be positive semi-definite. Now, on the other hand, if the coefficient that you factored out is negative, you'll change a positive definite function to a negative definite function and vice versa. And you'll change a positive semi-definite function to a negative semi-definite function. Indefinite won't change when you factor out a constant, whether it's positive or negative. Okay, so let's go ahead and have you work on one more problem on your own, and then you'll be all done. All right, so let's do quadratic classification. What you'll need to do is match the following functions with their classifications. And these are all given in a fairly simple form, right? They're given in a factored form so that you don't have to do all of this complete the square nonsense. You should be able to look at these and answer the question. So go ahead and hit pause and see what you think the correct answers are, and then when you come back, we'll show you the answers. Okay, welcome back. Let's go ahead and show you the answers here. The first function is negative semi-definite. It's a semi-definite function because it's a x plus y quantity squared. So this is of the form of this is a u squared form, but the coefficient out in front is negative. So that's why we have negative semi-definite. The second one is x minus y quantity squared. So that's of the form u squared, right? And so that one is a positive semi-definite. That's a positive semi-definite function. The third one we have is x plus y times x minus y. Now if I expand that out, I have x squared minus y squared, and we know that that's an indefinite function. And then finally, the fourth function is x squared plus y squared, right? And so we know that that's a definite function, and because the coefficients out in front are positive, it's a positive definite function.